I'd like to thank Bobby Joe for requesting this video. You're the first one. So the unit circle is a circle in the coordinate plane centered at 0, 0 with a radius of 1. So what that would look like on Desmos, it's a circle centered at the origin with a radius of 1. This is the basis for all of the calculations and everything else with the unit circle. Just remember, it's all happening on this. So the unit circle is very important for solving equations and problems with trigonometric functions, such as sine, cosine, and tangent, by memory without a calculator. So as you can see with this brilliantly made circle, all of these lines are on it, which have the following degrees. That was probably really sloppy, but you got the point. So what this represents, if you have, let's say this line, right here, it's labeled as being 30 degrees. What that means is that the angle it forms with the x-axis, or this horizontal line, that is 30 degrees. So you can imagine yourself turning 30 degrees from the x-axis and you would get to this line. But we don't really care about the degrees in pre-calculus. What we deal with is radians. So radians are in terms of pi instead of in terms of just normal numbers. Why is this? I haven't a clue. However, we will push through. I did not mean that to rhyme. So basically, what I like to think of radians as is just fancy degrees. So if you want to go from a radian to a degree, you want to multiply by 180 and then divide by pi. And if you want to go from a degree to a radian, you have to multiply by pi and divide by 180. So I'm not sure if this explanation for finding the radians of the unit circle is going to be very clear, but this is how I remember it. So how do we remember the radians of the unit circle? Well, first of all, we know that the unit circle is made up of 2 pi radians. So as you can see here, the radian of the start is 0. Quick note, if you do one spin around the circle, that adds 2 pi, but it lands you in the same place. So that's why 2 pi is also there. Now we know that if you go halfway to 2 pi, you get pi. So that means the radian of this side must be pi. We also know that halfway to pi is pi over 2. So the radian of this must be pi over 2. And then since this line is halfway to pi over 2, its radian must be pi over 4. So now we can add pi over 4s to get the radians of these other lines. So if we add pi over 4 to pi over 2, we get 3 pi over 4. We can keep adding pi over 4, so this is 5 pi over 4, and then this is 7 pi over 4. Now as you can see, I've moved some of the radians to the outside so we have more space. Now we still need the radians for all of these other lines. What do? Well, first of all, this first radian is pi over 6. So what we can do is keep adding pi over 6 to get the next ones. So one more pi over 6 would get us to 2 pi over 6 or pi over 3. Adding another pi over 6 would get us to 3 pi over 6 or pi over 2, which we already have. Then we can keep going for the rest of them. And that gives us all of our radians after rounding. So doing calculations with the unit circle, you're usually going to be plugging in these radians to a trigonometric function, sine, cosine, tangent, and then the output is going to be the points that these lines intersect with the circle at. So the points they intersect are these points right. Oh my god! Oh my god. Okay. Well, let's break it down, right? So let's just start with the points that intersect the circle on the horizontal and the vertical line, or the x-axis and y-axis. On the x-axis, the y values always have to be 0, because if the y value isn't 0, then it's not on the x-axis. Then the x values always have to be either 1 or -1, because the radius of the circle is 1. Now the same logic applies to the y-axis. If you're on the y-axis, then your x value has to be 0. If you deviate from that, then you're not on the y-axis anymore. And then the y value either has to be 1 or -1, so it's 1 away from the origin, and the radius of the circle is still 1. So let's just start with this top quadrant. How do we remember these points? Well, first of all, we know that every x and y value in here is going to be divided by 2. So I'll just write that in. So now we have this. So the numerators are going to be in order of counting, either from 1, 2 to 3, or 3, 2 to 1. So the way I remember it is just writing in 1, 2, 3, and then again, writing in 1, 2, and 3. Now something's missing, and that's square roots. We need the square root of all of the numerators. Now all the square roots are in. And one quick thing, you may notice that the 1s aren't square rooted, but that's just because the square root of 1 equals 1. And now, all of the coordinates are there. But now, you may be asking, Owen, you dumb, stupid child. We still have 3 quadrants left in this circle. How are we going to remember this? How am I going to pass the AP exam? Well, now that we have these coordinates, all we need to do is reflect them to other places in the circle. Since a circle is symmetric across the y and the x-axis, all we need to do to find the points in the other quadrants is make either the x value, the y value, or both of the point negative. Let's say we want to find the point here. We need to reflect this point across the x-axis. We know that the x value is going to stay the same because we're just reflecting it across that axis. The y value is what's changing since it's flipping all the way over here. So what we do is we make the y value negative. It flips across the x-axis, and then we have this point. Now we can repeat the same process to find this point and this point. So if we wanted to find this point, we make the x value negative, and then if we want to find this point, we make the y value negative again, which would restore it to its positive state. So now all we need to do is apply this to the unit circle. We take the quadrant that we already know how to make, and we flip them to other quadrants by making either the x-coordinate or the y-coordinate negative. So now that we know how to construct the unit circle, we need to figure out how to do calculations with it. So I'm not exactly sure which grade level sine, cosine, and tangent are taught in. From the first results of Google, it's either Algebra 2 or Geometry. So I'm going to assume you already have some knowledge, and I'm just going to go through this pretty quickly. So sine, cosine, and tangent are all functions that you can apply to an angle in a right triangle that is not the right angle. You can use the acronym SOHCAHTOA to remember what each function does. What sine does, it divides the opposite leg by the hypotenuse. What cosine does is it divides the adjacent leg by the hypotenuse. And what tangent does is it divides the opposite leg by the adjacent leg. As you can see, if you take sine of this angle, which is theta, it is b over c because it's the opposite leg over the hypotenuse. With cosine, it's the adjacent leg over the hypotenuse, so 8 over c. And with tangent, it's the opposite leg over the adjacent leg, which is b over a. Now, you might not have heard of this explanation for why the trigonomic functions work for the unit circle, but I think it leads to a deeper understanding of the topic. So at the end, I'll also give a quick summary of just the quicker way to solve out the trigonomic functions. So what you're actually doing when you use the trigonomic functions on the unit circle is you're using the trigonomic functions on these radians. So let's say you wanted to do sine of pi over 6. So your theta angle would be this angle, which is the radian pi over 6. The hypotenuse would be the radius of the circle all the time. So the hypotenuse is just 1, and then you can get the legs of the right triangle from the point. So the x leg, or this leg, would be the square root of 3 over 2, and then the y leg, whatever this leg, would be 1 over 2. Sorry, it's writing over the circle a little bit. So if you wanted to do sine of pi over 6, you would do sine of theta. Sine is opposite over hypotenuse, so the opposite leg is 1/2, and the hypotenuse is 1. Since it's 1/2 divided by 1, if you divide anything by 1, it's the same thing, so it's just 1/2. That means that if you do sine of any radian, the output is the y value of the coordinate that it corresponds to. Now, what if we wanted to do cosine? Well, we do the general same thing. We have cosine of this angle, which is adjacent over hypotenuse. That's the square root of 3 over 2 divided by the hypotenuse, which is just 1. So it's just the square root of 3 over 2, which is just the x value. Now it just gets a little more complicated with tangent. You'd do the tangent of the angle, which is the opposite leg over the adjacent leg. So it'd be 1/2 divided by the square root of 3 over 2. So that's just a little bit of computation, but this generally still works. So this is that little summary bit I mentioned earlier. So what exactly does this mean? If you do sine of any radian, you get the y value of the coordinate that corresponds. If you do cosine of any radian, you get the x value of the coordinate that corresponds. And if you do tangent of any radian, you get the y value divided by the x value of the coordinate that corresponds. So those are the basic trigonomic functions in the unit circle. You did it! Now, I definitely recommend trying to draw the unit circle from memory. Just remember those memory tricks, so 1, 2, 3, 1, 2, 3. And that's about it. You can comment below if you still have any questions, and make sure to like and subscribe so I can help the most people.